One of the main goals of JAXA's Martian moons exploration mission is to uncover the origin of Mars's two moons, Phobos and Deimos. A possibility is that the moons were originally asteroids that formed elsewhere in the solar system, but were captured by Mars's gravity as they were scattered towards the terrestrial planets. Evidence for this is that the moons resemble D-type asteroids. But what does this mean? Viewed from Earth, asteroids are seen as point sources, a bright, localized dot of light that indicates the presence of an object, but nothing about its surface. However, light reflected from the asteroid varies based on the asteroid's composition. This gives us a way to classify different asteroid types. The total amount of light reflected from an asteroid depends on how dark or bright the asteroid's surface is. We call this the albedo. Bright asteroids that are very reflective have a high albedo, whereas dark asteroids have a low albedo. We can also look at which wavelengths of light are most reflected by the asteroid. Plotting the intensity of different wavelengths on a graph gives the asteroid's spectrum. If the asteroid reflects more light with shorter wavelengths, we say the asteroid's spectrum is blue. Conversely, if most of the light is reflected at longer wavelengths, such as red or infrared, the asteroid's spectrum is said to be red. S-type asteroids, such as Itokawa, which was visited by the Hayabusa mission, have a moderate albedo and a red spectrum. The asteroids are primarily composed of silicates, which absorb light that has a wavelength of about 1 micron. This creates a characteristic dip in the light spectrum. C-type asteroids, such as Ryugu, which was visited by the Hayabusa 2 mission, are darker asteroids than S-type with low albedos. The typical spectrum is red, but flatter and featureless compared to S-type. C-type asteroids are thought to be rich in carbon molecules, such as organics, and minerals containing water. Both these ingredients are needed for life, which is why C-type asteroids may have helped bring habitability to our planet. D-type asteroids have very low albedos and a redder spectrum than either S or C-types. Light reflected from Phobos and Deimos resembles this class of asteroid, suggesting that they may be captured asteroids with a D-type composition. D-type asteroids are mainly found in the outer solar system, further from the Sun than either S-type or even C-type. They are expected to be very rich in both organics and water-containing minerals. If the Martian moons are D-type asteroids, they are evidence for what outer solar system material reached the terrestrial planets, helping us unpick what ingredients the young Earth received to start the journey that would make our habitable world.